Complex specified instructions and irreducible complexity, known concepts in computer science and engineering design. And how these point to intelligent design in the biosphere. In the ongoing debate about the origins of complex systems, two key concepts often discussed are complex specified instructions and irreducible complexity. While these terms are frequently associated with proponents of intelligent design, ID, particularly figures like William Dembski and Michael Behe, it is essential to recognize that the principles they represent are well established in other fields, such as computer science and engineering design. These disciplines operate with a clear understanding of complex systems and functionality that closely mirrors what intelligent design advocates argue for in biological contexts. Therefore, rejecting these concepts simply because an ID scientist coined the terms is not only unscientific but also irrational, as they describe features already recognized in both engineering and computer science. Understanding complex specified instructions in engineering and computer science. The term complex specified instructions, CSI, as popularized by William Dembski, refers to a system in which a set of highly complex, ordered elements comes together to achieve a specific, functional outcome. This concept is not unique to biology or intelligent design. In fact, in computer science and engineering, the precise arrangement of components to achieve a goal is foundational. Complexity in computer systems. In computer science, software is composed of numerous interrelated components, variables, loops, functions, and data structures that work in unison to achieve a specific task. The instructions that a computer program executes are not random, but intentionally designed by programmers. These instructions exhibit complexity due to the number of interacting components, as well as specificity, since each function is purposefully arranged to perform a designated task. For example, in the design of operating systems or complex algorithms, millions of lines of code must be arranged in a way that ensures each module interacts correctly with others. The exactness of these arrangements is non-negotiable. A single misplaced instruction can cause an entire system to fail. This demonstrates that specified complexity, where complex parts must be arranged with precision to achieve a goal, is a concept thoroughly known and applied in computer science. Specified functionality in engineering design. In engineering, complex specified instructions are equally important. Consider the design of a bridge or an airplane. Each component, whether a metal beam or an engine, must be placed and designed according to strict specifications. Randomly assembling parts or slightly misaligning components would result in catastrophic failure. Engineers carefully design each aspect of the system so that all components work in harmony, delivering the desired functionality, such as structural integrity or aerodynamic efficiency. Much like in computer science, the design process in engineering demonstrates that complexity and specificity are prerequisites for the development of functional systems. Thus, the concept of complex specified instructions is deeply embedded in both software and mechanical systems. Irreducible complexity in engineering and computer systems. Irreducible complexity, another term popularized by Michael Behe, refers to systems in which multiple interacting parts are necessary for functionality, and removing any one part renders the entire system non-functional. Critics of intelligent design often reject this concept on philosophical grounds, but irreducible complexity is not just a biological or theological idea. It is a well-known and scientifically grounded reality in both engineering and computer science. Irreducible complexity in computer systems. In software design, there are countless examples of systems that exhibit irreducible complexity. For instance, consider a relational database that stores and retrieves data through a structured query language, SQL. If you remove critical components like data indexing, query optimization, or even basic data retrieval mechanisms, the entire system becomes dysfunctional. All these elements are necessary and work interdependently to allow the database to perform its function. Another example is a network protocol stack, where layers of protocols like TCP, IP work together to facilitate communication between computers. If you remove one protocol layer, such as IP, Internet Protocol, the system breaks down entirely, no communication is possible. These systems cannot be simplified beyond a certain point and still retain functionality, making them irreducibly complex. Irreducible complexity in engineering systems. Engineering systems often exhibit irreducible complexity. A good example is the design of an internal combustion engine. The engine requires pistons, cylinders, fuel injectors, and timing mechanisms, all working together in precise synchronization. If any one of these components fails or is removed, the engine will cease to function. Each part is indispensable to the system's operation. The concept of irreducibility also extends to aerospace engineering. An airplane's flight control system relies on multiple interdependent subsystems, hydraulics, avionics, control surfaces, and more. If one critical subsystem malfunctions, the entire control mechanism is compromised, potentially leading to catastrophic failure. Like the biological systems described by intelligent design proponents, these engineering systems cannot function unless all components are in place and properly coordinated, demonstrating irreducible complexity. Rational acceptance of established concepts. Given that both complex specified instructions and irreducible complexity are well known in fields like computer science and engineering, it is irrational to reject these ideas simply because they are associated with intelligent design. Doing so ignores the broader context in which these concepts have long been recognized and applied. Rejecting these terms because they are tied to the ID movement fails to acknowledge the transdisciplinary validity of these concepts. Misguided rejection. The scientific community's critique of intelligent design often focuses on the ideological or philosophical implications rather than the empirical validity of concepts like CSI and irreducible complexity. However, in fields like engineering and computer science, these concepts are not seen as controversial. They are essential principles for building functional, reliable systems. By extension, it is entirely consistent to argue that these same principles apply to biological systems. Transcending terminology. The terms may be new, but the concepts are not. Whether we call it complex specified instructions or simply functional programming, the underlying reality remains the same. Complex systems with specified arrangements of parts exist, and they require an intelligent agent to bring them into being. Similarly, irreducible complexity, whether it is referred to in biology, computer science, or engineering, describes systems that must have all components present and functional for the whole to work. Empirical consistency across disciplines. The same principles that govern the development of computer programs, software systems, and engineered machines are empirically consistent with the idea that biological systems may also exhibit irreducible complexity and specified complexity. It is therefore irrational to dismiss these concepts when applied to biology simply because they are associated with intelligent design. Conclusion. The concepts of complex specified instructions and irreducible complexity are well known and widely accepted in fields such as computer science and engineering. They represent essential truths about the organization and functionality of complex systems, which require a specific arrangement of parts to achieve a goal. These concepts are not unique to the intelligent design movement, nor should they be dismissed because ID scientists coined the terms. To reject these ideas outright because they have been applied in the context of intelligent design is to ignore the extensive, well-established evidence that shows their validity in many other domains. Whether in biology, software engineering, or mechanical systems, the functional arrangement of parts and the necessary interdependence of those parts are universal features of complex systems that point strongly to the involvement of an intelligent mind. Therefore, the recognition of complex specified instructions and irreducible complexity as features of reality is entirely rational, and their application extends far beyond any philosophical debate. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.